Hey, welcome back. This is Math 0965, and we're going to investigate factoring trinomials this time. In the last section, we were kind of factoring out the greatest common factor from binomials and trinomials as well. But this time, we're kind of doing, instead of reverse distribution, we're going to be doing reverse FOIL. Okay. Okay, in particular, we're only going to look at trinomials where the leading coefficient is 1, mainly. Okay, so first off, what exactly are we doing? Factoring, or sometimes I will call it reverse FOIL. Okay, so remember FOIL. First, outer, inner, last. When did we do that? We did that when we were multiplying two binomials together. So for example, x plus 2 times x minus 9. So how did that work? It's first x times x, so x squared. The outer, x times negative 9, minus 9x. The inner, 2 times x. And then the last, 2 times negative 9. And then we combine the like terms in the middle. So we get x squared minus 7x minus 18. Okay, what we want to do now is go, of course, in the other direction. Now we want to reverse this process. Okay, and the hard part is kind of figuring out the numbers in the middle that will add together to give you this last term. All right. Let me just show you an example. So x squared, what we're getting into, this is kind of ultimately what we want to do. We want to factor it into two binomials. So, the first, well, in this form, when you have this form, so we'll talk about different forms of trinomials. You'll have to have x and x, and then it's going to have to be plus and plus because of the way the signs are. And then you need two numbers that multiply together to give you 8, but then add together to give you 6. Okay, so this is going to be kind of a trial and error thing, and it's not as easy as FOILing. Okay, so if you think about 8 and factor it, it's 8 and 1, but 8 plus 1 is 9, so it's not going to give you 6. 4 and 2. 4 times 2 is 8, and then 4 plus 2 is 6, so those will work. So your factorization, x plus 4, x plus 2. And of course you can FOIL. I always FOIL it back out in my brain to make sure it works. X squared, first, outer, inner, last. Okay. And of course 2x plus 4x gives me 6x. And I got back to where I started. Okay, so that's what we're after. We want to go through and kind of do it in a very programmatic way by identifying forms, almost like we're computers. And hopefully after a while it'll be like riding a bike though. Okay, so we want to establish these techniques for all the different forms. So this is now section 2. And the first form we'll see is x squared plus bx plus c. And whenever you see this, you're going to automatically, and I advocate, set up your parentheses first, and then it's kind of just a puzzle. Turns into a puzzle kind of problem. So in this form, it's always going to be x and x. And then because of this sign, this plus sign here, you need something times something, which is positive. And we all know it's either going to be a positive times positive is positive, or negative times negative is positive. But you need the outer and inner to add to be a positive. So you need it to be positive, positive. In other words, you need the signs to be plus and plus. Okay, so let's look at some examples. So x squared plus 7x plus 6. So automatically the first thing you do when you see these problems, write out your parentheses. And because it's plus plus, the signs in here will have to be plus and plus. And of course, you always get x and x. Okay, then it's just a matter of saying to yourself, what times what gives me 6, but adds to 7. And usually underneath the 6, I'll do a little factoring. So 3 times 2 is 6, but 3 plus 2 is 5, right? And I'm looking for two numbers that multiply to give me 6, but add to give me 7. The only other factorization is 6 and 1. So 6 times 1 is 6, but 6 plus 1 is 7, and that's what we want. We want the outer and inner to give me 7, so it must be 6 and 1. And you always check these in your brain, okay? You could check it, you could write it out, but if you're doing your checking, you're not going to miss the question on the test, because it'll definitely be correct. Okay, so here, first, x times x is x squared, the outer, 1x, the inner, 6x, and the last 6. So x plus 6x is 7x. Yeah, we got it. Okay? So there's no reason to get these wrong. You should get 100% on these on the test. Okay, so we just want to look at a whole bunch of examples, hopefully get you acclimated. Set up your parentheses. The trinomial has plus plus, so this is also going to be plus plus. It just has to be that way. And then you start factoring 10. So 10 and 1. 10 plus 1 is 11. That won't work. 5 and 2. 5 plus 2 is 7. So that does work. And then in your brain, you're foiling this back out. X squared outer. So you get really good at foiling. Inner. And it works. And of course, these are your answers. Okay? This is your answer. This is your answer. Okay? All you're doing is factoring. Let's see what's next. X squared plus 13x plus 12. Okay, set up your parentheses. So get the easy stuff out of the way. Right? And then you can kick back and kind of just play with the numbers. It's kind of like picking a lock. 12, 3 and 4, but 3 plus 4 is 7. We're looking for a 13. 6 and 2 will be 8. That won't work. But 13 and 1 will work. Right? And then FOIL it out in your head. X squared plus outer x plus 13x plus 13. Oops, that doesn't work. Right? So I screwed that up. It should be 12 and 1. I'm sorry. So it's a good thing I checked, right? 12, and then x plus 12x, and 13x is 12, and then it works. Okay, so that's our first form. That's the easiest form. The second form then, and I'm trying to figure out which Roman numeral I'm on, 3. The next form will be x squared minus bx plus c. So if you have something like this, you know you need the two last terms to multiply together to be positive. But you need them to add together to be negative. And the only way that's going to happen is if you have a negative times a negative. Okay? Because, so the form will be x minus and then x minus. So it's the only way you can get that b to be negative when you add the inner and outer together. So let's just do a bunch of these. So x squared minus 13x plus 40, and then, you know, as usual, just write down automatically your parentheses, and then because of the signs, it's minus plus, it has to be minus minus, and then get your x's, and then kick back and figure out the two numbers. So 40 is the same as 4 times 10, but when you add those together, you get 14. What else? 8 and 5. 8 plus 5 will work. Okay, so 8 and 5. And then FOIL it back out in your head. Squared outer minus 5x inner is 8x plus 40. 8, 5, 13. Yep. Let's see another one. X squared minus 8x plus 16. So you're going parentheses, parentheses, because of the signs, has to be minus, minus. And then you're thinking, what times what is 16, but adds to be 8. So 16 and 1. No, that's 17. 4 and 4. Yeah, that'll work. X minus 4. Here's one with a variable y instead of x. No big deal though. Just use y instead of x. So instead of x minus, you'll have y minus. There's only one factorization for 7, so there's only one possibility here, just 7 and 1. So y squared, outer, minus y, inner, minus 7y, last, 7. So does it work? Yep. Okay, the last two forms, and we kind of group these together. X squared minus bx minus c, and then x squared plus bx minus c. And they have the same setups. That's why we kind of put them together. So to get the last term, this minus, the signs have to be plus minus. So positive times a negative will give me a negative for the last, that c value. The x is going to be x, the first position, always x times x for all these problems. So you don't have to do much thinking there. And then this time, you're looking for two numbers that multiply to give you c, but then subtract to give you b. So it's a little bit different. And in particular, it's always going to have the kind of peculiar form that the bigger number that is always going to be kind of have the same sign as this second sign here, the negative. So the bigger number would go with the negative, and this would be the smaller. But usually you can kind of finagle that answer just by kind of guessing. So in the second case, the bigger number would go with the positive because this term is positive. And then the smaller number would go with the negative. Okay? Okay, so let's do a bunch of these. X squared plus 3x minus 28. Okay, so you see that minus 28, automatically, you know, you have a plus minus situation on your hands. So x and x. And now, instead of adding the two numbers together, I'm subtracting. So 28 and 1, that's 27, that won't work. 4 and 7, right? When I subtract 4 and 7, I do get 3, negative 3. 4 minus 7 is negative 3, but the sign doesn't really matter. It's just when you subtract them, do you get the same sort of number as you got in the middle? Yes. And then I need the bigger number to be 7. Okay. So I need the bigger number to be positive. Sorry, 7 and 4. So if you FOIL it back out, you'll see it work. I'll have x squared outer minus 4x inner plus 7x minus 28. And then when you combine the like terms, you get what we want. If you accidentally switch the signs, you would catch that when you do your check. Okay, so even if you don't kind of remember the big and small thing, you can kind of just guess and then FOIL, and if it doesn't work, just switch the signs. Okay, so if you set it up first as x minus 7x plus 4, first x squared outer plus 4x, excuse me, one second. Okay, so first x squared outer 4x inner minus 7x, and then last minus 28. And if you combine like terms here, you see x squared minus 3x minus 20. And so that's why you want the bigger number to be positive, because when you combine them like that, if the bigger number is positive, you end up with a positive for in your second sign position there. Okay. But like I said, even if you do screw it up, when you go the check by foiling out in your brain, you should be catching it. And then in that case, you just switch, you know, turn this one plus, turn this one minus, and you'll have the answer. Okay, so let's look at a couple more examples here. Here's one with a different variable. Set up your parentheses. It's, you know, you see that negative in the second position here, it's automatically plus minus. Instead of x times x, you have y times y. And then you want two numbers that multiply to give 24, but subtract to give 5. Right? So 12 and 2, no, that's not going to work. 8 and 3, right? 8 and 3, you subtract them, you get 5. We need the bigger one to be positive, and there we have. And then FOIL it back out in your head. Squared, first, outer, inner, less. And it works. Okay. Let's try x squared minus 4x minus 5. So again, this guy here is negative, so automatically it's going to be a plus minus scenario. And then you want two numbers that add the 5, subtract the 4. So 5 and 1. There's only one possibility. I need the bigger number to be negative. So the first, x squared, the outer minus 5x, the inner plus x, the last minus 5. And that works. This one's very similar, but it has different signs involved. This is a plus plus. So the second guy is positive, so it's either minus minus or plus plus, but if this is positive, it's plus plus. So you have x plus, x plus. 5 only has one factorization, 5 and 1. So the only possibility you can have is 5 and 1. But there's a problem, right? You try to FOIL it and see if you get back to where you started. So first, outer, inner, last, you get x squared plus 6x. It doesn't work. And this is the only possibility. So what does that tell you? That tells you basically that this thing is prime. You can't factor it. So those do happen. Let's look at one that's kind of has some weird variables. So you can have x, you can have y. Here's one with an r, as in random. R squared minus 15r minus 16. So this has a negative in the second position, so you know it's plus minus. Instead of xx, it'll be r. And then factorizations of 16 that subtract give me 15. Okay, so 4 and 4, 4 minus 4 is 0, that don't work. 8 and 2, 8 minus 2 is 6, nope. 16 and 1, 16 minus 1 is 15, good. I need the bigger number to be negative, so it works out. And then FOIL it to make sure it works. First, outer, inner, and then last. Okay, and it works. Okay, what happens when I add two variables, another variable to the mix? Okay, and it turns out it's kind of just the same game, except you're going to slip in an extra variable in your factorization. So I'm up there, look what number, I'm on 4. Okay. So two variable problems. So our forms, as of right now, what do we have? X squared plus by plus c, or sorry, bx plus, I'm going to leave a little space, c. That would be one form, and then we have, leave a little space like I did. And then you have x squared minus bx, leave a little space, plus c. And then you had x squared plus bx minus c. And then we had x squared minus bx minus c. So what's going to happen with two variables, they're just going to slip a y in here, in these positions. Like that. And all the factorizations are pretty much going to work as before. It's just going to sneak that extra y into the factorization. So for the first one, you know, as usual, it's x plus. That part stays the same. It's just for this other part, we're going to kind of slip in a y. And then the only problem is trying to figure out what goes in front of the y. So I'll put a little blank there. Okay, but it's almost exactly the same as what we did above. So this one is going to be, you know, negative, negative. Okay. And then we're going to have to figure out what goes in front of the y. And then this guy is a plus minus scenario. where the bigger number has to go in front, has to be positive. And then finally, this is also a plus plus, but the bigger number has to be negative. Or sorry, plus minus, but the bigger number negative. And we slip that y in here. And for the test, you're going to have to do this without notes. So as you go through, have this out for reference, but try to do it without. Try to do it without having to look up the formula every time. So hopefully you do enough of these that you'll just get sick of looking it up and you'll have it kind of embedded in your brain. Okay, let's dive right in and look at some of these. So x squared plus 6xy plus 8y squared. Okay, so automatically it's a plus plus, so x plus, x plus. And then, you could put in the y's if you want, y. And then we're looking for two numbers that multiply to 8 but add to 4, right? Add to 6 rather. Okay. So 8 and 1, no. 4 and 2. Right? 4 plus 2 is 6, so that will work. So I just put 4y and then 2y. And I just only got a little too flamboyant with my. I can't leave it like that. Let me rewrite it. X plus 2y. Sorry. Let's try another. X squared minus 9xy plus 14y squared. Okay, this is a minus minus scenario. So x minus, x minus. Look for two numbers that multiply together, give me 14, but add the 9. Okay, so 7 and 2. So you go 7y and 2y. And of course, FOIL it out to make sure it works. So first, x squared, outer minus 2xy, inner minus 7xy, last plus 14y squared. Okay. 2 and 7 is 9, so that works. This next one's the video quiz. Okay. So this is the second video quiz problem that will be due next week. Okay. The 6.2 video quiz problem. So you put this in with the 6.1 problem. You write it out just like I write it out. Okay. Lets me know that you've been doing your job. X squared minus xy minus 30y squared. So this will be a plus minus scenario. Plus minus. Need two numbers that multiply the 30 but add, or rather subtract in these cases, to be 1. Okay. So obviously 3 and 10 I don't think will work. That will be 7. 6 and 5. Right? Okay. And we need the bigger number to be negative. And of course tack in that y. Don't forget the y. And then factor it back out, make sure it works, or FOIL it back out. X squared outer minus 6xy, inner plus 5xy, last minus 30y squared. Looks like it works. Okay, so that's your video quiz question. Next, some different variables, so a's and b's. A squared minus 18. A b, and my b's kind of look like 6s, but you can tell there's a little kind of corner at the bottom of it. See how my 6 is curly up here to the right? My b's have a corner on them. Okay, plus 80b squared. Okay, so instead of x's and y's, just use a's and b's. This is a minus minus scenario. Instead of x's, we have a's. I need two numbers that multiply to give me 80, but add to 18. So that's just 8 and 10. Doesn't really matter what order you put them in. And then FOIL it back out to make sure it works. And it works. Okay. Now, whoops, it didn't work, right? Because I forgot my b. I'm going to wedge a b in there, and then it'll work. Good thing I check. All right. So far, all of our factoring if you look at the title of the section, I don't know if I copied it correctly out of the book, but up till now, the leading coefficient, which is the x squared, the number on the x squared, right? So our forms have been something like x squared plus bx plus c. The leading coefficient is whatever is on the x squared. And right now, the leading coefficient has always been 1, okay, for every one of these problems. So you may be wondering, what the heck, this is great, but what the heck am I going to do if I have a polynomial that has like a 3 in front of it? Well, the first thing you always want to do is kind of check to see if you can factor out a GCF. Okay? So usually when you attempt these problems, you begin by factoring out a greatest common factor. So let's take a look at some of these types. So for example, we have 3x squared plus 15x plus 18. And I notice, look, 3 divides all 3 of these things. So I can pull out the 3, and I'm left with x squared plus 5x plus 6. And then this part here, I can factor using the strategy I've used. Don't forget, though, to bring the 3 along for the ride. That 3 won't magically disappear. It'll be 3 times something times something. And so what are those something? So it's a plus scenario, x plus. Now you need 2 numbers that multiply the 6, but add to 5. So 3 and 2, I believe. And of course, you can FOIL it back out to make sure it works. First, outer, inner, last, times 3. And then we have, so this takes a little longer, and then distribute. Yeah, it works. So it's a good habit to get into. It's just always kind of factoring out the GCF first. Let's look at a whole bunch of these. And then we just have one extra thing to do after this, and then we'll. So let's look at one that has some weird variables. An r variable, 3r cubed minus 9r squared minus 54r. Okay, this time there's a constant of 3 that can be pulled out, but also a variable as well, right? Each one has a factor of r. So I'll be left with r squared minus 3r minus 3 goes into 54, 3, 24, 18 times 18. And then I can go ahead and factor that thing. It's a plus minus scenario. Plus or minus. And what times what is 18, but subtracts to 3. So that would be, I believe, 6 and 3. And then the bigger number has to be negative. 6 and 3. Let's look at one that has multiple variables. X cubed y minus 2x squared y squared minus 3xy cubed. Okay. Looks like each term has a factor of x, and then each term has a factor of y. So I'll be left with x squared minus 2xy minus 3y squared. Then I could factor this. It looks like a plus minus scenario. X plus, x minus. Well, 2 numbers that multiply the 3, but subtract to be 2. So that's just 3 and 1. The bigger number has to be negative. And then don't forget the y. So this would be 1y and then minus 3y here. And of course, you could refoil that out and everything. First, x squared, outer, minus 3xy, inner, plus xy, last, minus 3y squared. And then we have x squared minus 2xy minus 3y squared. Okay, and it looks like that works. Okay, the last thing we will look at is sometimes you want to factor out a negative because you want the leading coefficient to be positive 1. So that's just the way we've been learning things. Okay, so factoring, oops, 1, section 5, and 6. Factoring out a negative. example, negative 16t squared plus 80t plus 96. So I'm going to factor out not just a negative, but also any GCFs. So I think I can factor out 16 from all of these. And I'm going to make it a negative 16. So now the signs on the inside will be plus, minus, minus, right? So you end up with positive t squared minus 5t and then minus 6. And then you can factor that. That's a plus minus scenario. 2 plus, 2 minus. And we need two numbers that multiply to 6, but subtract to 5. So 6 and 1. And we need the bigger number to be negative. 6 and 1. And then we could, make sure it works. So t squared outer minus 6t inner plus t last minus 6. Does that work? Yeah. Okay, so we're good to go. Let's go and look at some of the my math lab problems. Usually those can be kind of challenging. And see how we are there. Okay. Yes, I want to continue. Okay, so what are we doing here? Use the negative of the greatest common factor to factor completely. For example, negative x squared minus 4x plus 12. So just like what we did here. This is the only thing you factor out is a negative 1. So I'll have x squared plus 4x minus 12. And that'll be negative. This is x plus x minus. And then we need two numbers that multiply the 12 but subtract the 4. So I think 6 and 2, right? And the bigger has to be positive. 6. And let's see if it works. So negative, hopefully it'll be okay with just putting negative there. X plus 6 times x minus 2. Yay. What's next? So we'll just do a whole spiel of these. We have to look at what we're up against. Negative 2x cubed minus 28x squared plus 30x. Again, I'm going to factor out that negative. I always want a positive leading coefficient. And in this section, I always want a leading coefficient of positive 1. So I'm going to factor out a negative 2, but I can also factor out an x. Each term has an x. Right? So you end up with x squared. Then this will become positive 14x. And then this will become negative 15. And it's a plus minus scenario. So 15 and 1. And we need the bigger number to be positive. If it doesn't factor, you just click on the other, the polynomial is prime, but it doesn't happen as much as you would think. X plus 15 and x minus 1. Let's see what, oh, look at this guy. It's getting scary, huh? 2x squared y squared minus 68x squared yz plus 66x squared z squared. Okay. 3 variables. Looks like I can factor out a constant of 2, and everybody has an x squared as well. So I can factor out a 2x squared from each term. Make sure you use equal signs to connect everything. So I can factor out 2x squared. I'm left with y squared minus 34yz, and then plus 33z squared. Okay. So this will be 2x squared, and this is a minus minus. And we need two numbers that multiply the 33, but add the 34, so just 33 and 1. And then don't forget to slide in a z. Okay, so this would be 1z or just z. Okay, so 2x caret squared y minus 33z, parentheses, and then y look at this guy. So it looks like I factor out an a plus b out of every term. So I have a plus b x squared minus a plus b 4x minus 45 times a plus b. So first things first, factor out this a plus b from every term. Factor out that binomial. Okay, so you'd be left with x squared minus 4x minus 45. And then see if you can factor that x squared minus 4x minus 45. So that will be a plus minus scenario. 45 is the same as 9 times 5. 9 minus 5 is 4, so that's good. We need the bigger number to be negative. That should be it. A plus b times x plus 5 times x minus the name. Okay. Yeah, you can have decimals, no big deal. Just x squared plus 0.9x plus 0.18. So this would be, it's a plus plus, right? X plus, x plus. I need two numbers that multiply to give me 0.18, but add to be 0.9. So I'm thinking 0.2 and 0. No, that ain't gonna work. Was it 0.6 and 0.3? I think that'll work. And of course you go 0.6 times 0.3, and that'll be 18. 1, 2 decimals, 0. Yeah, that works. Okay, so 0.6 and 0.3, and of course multiply them out. We'll end up with 0.6x plus 0.3x for your outer and inner, and that'll add to the 0.9x. So you know, how did I get 0.6 and 0.3? When I'm thinking of 0.18, you can kind of think of it just as 18. You know, and 18 would be like 18 and 1, and then 6 and 3. The only factor 9 and 2. Okay, but because we have 0.18, you got to make it 0.6 and 0.3, or 0.9 and 0.2, or you know, 0.18 and or 1.8 and 0.1, I guess would be how it would work. You just have to be a little more familiar with multiplying out decimals, right? You can go to your calculator and see the truth of it. It's not something I expect everybody to be, you know, everybody does multiplication by decimals every day. I don't think so. But it's 0.8 times 0.3 is 0.24. It's 1.8 times 0.1. That'll just move the decimal place over 1. It's 0.18. But yeah, 0.6 times 0.3 is 0.18. So you'll get that last term working out. Let's look at another one. Oh, fractions. Yeah, that'll happen. X squared minus 2/9 x plus 1/81, 1/81. X, this is a minus minus. Need two numbers that multiply to be 1/81, but add to be 2/9. 81 is a special number. It's one of these perfect squares. So you got to become hopefully really familiar with the perfect squares, like 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5, 25, 6 times 6 is 36, 7 times 7, 49, 8 times 8, 64, 9 times 9, 81. So 1/9 times 1/9 will give you 1/81 for the last term that you need in your FOIL. Right? So let's FOIL this out and make sure it works. So get first, x times x is x squared, outer minus 1/9 x, inner minus 1/9 x, just 1/9 times x is 1/9 x. Last, negative 1/9 times negative 1/9 will give you a positive 1/81. And then if you add the two fractions together, you just add the numerators over the common denominator, and you get what we needed. So if you have anything else, oh, another application. Factor it completely first. So part A, we're doing an application on trajectory. So a stone is thrown directly upwards from a board that's 288 feet high, and after 2 seconds, its height is described by this polynomial, which I'll call h. And in part A, they want you to factor it completely by factoring the negative 16 out. Okay. So h will be negative 16 t squared, the signs change, minus 3t minus whatever the heck 288 by 16 is. And then we want to factor that trinomial. Okay, so h will be negative 16 times, this is a plus minus. We need two numbers that multiply to be 18, but subtract to be 6. That would be 6 and 3. The bigger number has to be negative. So let's see this. 16 times t plus 3 times t minus 6. Evaluate both the original and its factored form at t equals 2 to get the same answer for each. Let's just put it in the factored form. They will be the same. We saw that in the last section. So h of 2, that's the way we kind of write it, be negative 16 times t plus 2 plus 3. So it says plug in t equals 2, and then 2 minus 6. So we have negative 16 times 5. 2 minus 6 is negative 4. So we have negative 16 times negative 20. So it would be I think it's 320. And that would be basically where the ball is located in our space. Error. 320. Yeah, same answer. 320. Did you get it? Yeah. Okay. So hopefully that'll get you through the homework and everything, and get you a ton of practice. You need tons and tons of practice. So this almost becomes automatic, so you can do these in your sleep. Thanks for watching, and we'll see you next time.